I don't see, hold on, I'm waiting for this option. There we go. Try that. We will. Oh, there it is. Okay, Eric, am I sharing screen now? Anyway, at the bottom of mod 11, 12, and 13 is this review for integrals. And there's, I don't know what these two links are. I think they're Desmos that have review for midterm and integrals, but you don't have an integrals test. I decided to grade your project instead, so I'm not grading the integrals test, so you can look at it. You can look at the video, you can try to get an idea what sort of questions will be. This test was supposed to help you get an idea of what sort of questions there would be on the final. That's why it existed. What I discovered is there wasn't enough time for people to make changes between this test and the final, so you're just going to get the same grade on the final, so might as well do a project instead. You'll get a better grade, maybe. Because if you get a good grade on the final, then that's great. If you're going to get a bad grade on the final, this test is a good warning. It certainly tells me you're going to get a bad grade, but then you get a bad grade. And so it's not very helpful. Okay? All right. That's all that's left in the class. There's really, as far as topics go, today I'm finishing up. So where's my thing here? So we haven't done them. So let me just say, we did optimization or 7 integrals. We did some summation notation we did before the midterm. Approximate area, definite integral, average value. These should all mean something to you. The fundamental theorem of calculus should also mean something to you. Integration by substitution is what we started last time. Okay, what I'm doing today is evaluating definite integrals. Then you'll see there's one more topic that's not tested at all called area as a limit. And then there's a bunch of dribs and drabs stuff that has to do with review. There's a few things I want to do. I probably will, next week, there's a good chance I will not be here on Tuesday. I will let you know long beforehand, but I will definitely be here on Thursday, and the following Tuesday after that, there's a good chance I'll be here that Tuesday. There's a good chance you won't be. So Tuesday before Thanksgiving, so that's what you're going to ask me. Why? Oh, no. We're definitely having class on Thursday. The next Thursday, I'm definitely around. And I'm around on Tuesday, which is a Thursday schedule, I think. I'm around then. And I will teach as much as I can stand to teach. But I'm just telling you, I will be here, but next Tuesday I may not be here. So since quiz 10 is due next Tuesday, I'll probably extend it to Thursday. Now, once I extend it to Thursday, once it's done on Thursday night, one of the other things I was thinking about doing, and I haven't decided yet, but I'm thinking about, I'm finalizing your grades from the quizzes. In other words, I'm going to carve them in stone. Those are your grades, and then I'm going to open up all the quizzes. Okay, so you can use them to study from for the final. Okay, it's just very, yeah. So that's what I'm going to do, I think. But I haven't decided yet. Seems fair. Some people missed quizzes and stuff and don't have them to study from. And it's really hard for me to open up a quiz here and a quiz there. So I'm just going to open up all of them. But for people who did the quizzes, I have to count the grades. Okay. Any other questions on this? So that's how the rest of the course is going to play out. And then we have Thanksgiving. And during Thanksgiving, so on next Thursday, Sebastian, what I'm going to do next Thursday is review quiz 10. And I'm going to give you all the stuff you need to do your project over Thanksgiving. Because it's due somewhere in the beginning of December. I forget, it says when it's due. It says when it's due right here. Project is due on the 7th. Okay, and what I mean by due is that project is probably going to be submitted on you have a worksheet and you're going to submit the worksheet, and then you're going to submit a video. That video is going to be put probably on Harmonize. It's going to be a 5-minute video of you presenting all the great stuff that you have in the worksheet. And then I'm going to play them to the class. We're going to watch them. And if they're too long, we're not going to watch them. So don't make them more than 5 minutes. But yes, I want to make a video. I want you to record them as videos. It goes a lot better if it's a video. All right. Any other questions? Yes.
Do you have a sample of like past projects that we can based on, like use it as a guide?
I will Thursday. It will all be clear on Thursday.
Okay.
All will be revealed a week from today. But I want you to finish up 10 and stuff. So that's what I was going to do today, is finish up 10. You should have finished up your discussions. I don't have to go over the discussions, do I, Deb? Did you all do this last time? You might 10, so that was due last time. Approximate area. I see 4 of them here. I see 3 of them. Acacia, Slade, Sebastian, any questions on these? I can look over them now, or I can wait till next time. See what Acacia has. Okay, you see you have this capital F is the antiderivative. But for a quartic regression, it's the antiderivative, and you're subtracting the b minus a, and you're getting about the same answer that you do using, how many rectangles are you using here, Acacia?
I don't remember.
It says it right there. N equals.
Oh, sorry.
Say it. Say it.
The rectangles of 60,000.
Yep, that's what I wanted to hear. And Jonathan says, according to page 1 and 13, I was studying using 60,000 rectangles. Evaluated at the left one, the average grade would be 50. Oh, look what you did. I don't think that's right. Jonathan,
what did I do wrong?
you gave me, these are, what you gave me is 550% hours. If you want to take that 550 and divide it by 12, then give me that number.
Okay, I'll fix it.
Because 550 divided by 12 is what?
45.83.
So that's the average grade. With all those rectangles, you're still coming up with an average grade of 40. You know, you found the approximate area, but you didn't, yeah. But that's that you either going to have to add percent. You could just say the grade, don't say average grade, just say the grade would be 550% hours. Or you could say the average grade doing that between 1 and 13 hours of studying would be like 48%.
Okay, I'll fix it. Thank you.
Or you could say them both. Either way, it's fine. Okay, so let's see. That was your post. Slade. You're using how many rectangles, Slade? I see you're here, so you can answer that question.
Yeah.
How many rectangles are you using? Right there. N equals.
I can't see. 800,000.
800,000. Good. Did anyone reply to you? Selena did. According to the quartic regression between 20 and 100. Selena, that's not. No. It's not 20 and 150 BFFs. It's 20 and 150. That's the salary.
Yeah,
So
I know. I'm gonna fix that. I realized that I made a mistake. I saw it.
Right. And then you wouldn't say the total salary unit. This would be the number
The
of
BFFs.
BFF hours. Again, I would maybe divide that number by 130 to get the average number of BFFs. But
Okay.
It's using 800,000 rectangles to get the same answer you got last time exactly. So
Yeah, okay.
okay, good. All right. Who else? Sebastian. Sebastian, how many rectangles are you using? 1,000. Except I have a problem. You have a problem. These things in the box should be the same. So you're using Q of 5 minus Q of 1. You should be using capital, because you're using exponential regression or something?
Yeah,
Uh,
they don't work with the entire people.
Okay, so you can't use little q. The little q you can't use. You have to use capital Q, which would be the antiderivative. You need to find the antiderivative of your regression. That's harder than you think, because do you see this number right here, that line at the top? That's for the quartic regression. That's the antiderivative of the quartic, which everyone else is using. But if you're using exponential, you have to actually figure out what the antiderivative is. It isn't that hard, but I can help you with that later if you want. If you're going to continue to use the exponential, we only have this is the last submission, so. What? Did you submit? Are you in their group?
No, I'm in a different group.
Oh, well, I haven't gotten to it yet. I still have more posts. According to Curtis, between 1 and 5 months, 4,000 were divided and pointed out approximately 407 millimeter months. Okay, good. So that's 407 micrograms per millimeter months. That's the units. That's fine. But what you need to do is make sure that, I think this is right though. So what you don't have is the antiderivative working. You don't have the fundamental theorem part working to check it with. And then when I see those don't match, then I get concerned. Maybe I won't be because I know why I did it. Is this you? Huh? See those boxes match, and they match this, and they got, you used how many rectangles? 75,000 rectangles. And then this is population years, so that'll be population years or billion people years. Okay, you go away. Okay, so Pam she wrote it out in notation, and is there someone else in your group?
There's 2 other people in my group. It's Pavani and Luke. I don't think Luke was here last class.
Okay, last night. Who else?
And Pavani.
She's here. Pavani, since you're the missing person, you're going to have to say this in words. So according to the quartic regression, between what years is this? Between
2010 and 1980.
Okay, to say it the other way around, between 1980 and 2010, there were 170.66 what?
Billion people years.
Using how many rectangles approximated from the left side? She said it. How many rectangles?
75,000.
Yep, there you go. Okay, nobody uses 75,000 rectangles, but we do. Okay, good. Was there another group? Did I get everybody? I feel like there's a 4th group. Hold on. No, Acacia. I got Acacia. I got all the groups, yes. Acacia. Alicia. Acacia. Slade and Sebastian. Okay, good. All right, so those were good. So clean them up. And then we'll be done with them. As I said, the last thing you're going to do is just a discussion. Just going to tell me what you think of the class. All right. Next thing. Back to lesson 10. Okay, 10. Okay, so let's look at the homework with solutions. So, as a review of what we did last time, we undid the chain rule. Remember the chain rule? The chain rule was this. If I said, take the derivative d dx of parentheses x raised to the 9th plus 8. Okay, and that whole thing is raised to the 3/2. What would that give you? This is just derivative. There's nothing fancy here. What's the derivative going to give you? It's a power rule. So you have to do what?
Or bring down the three.
The halves. And then you leave, then you do the, which takes 1 from the 3 halves, and that gives you 1/2. What do you do with that stuff on the inside?
Leave it.
You leave it alone. Right? Boom. And the next thing you do is then you take the derivative of it. Can you tell me what the derivative is? 9x to the 8, 9. X raised to the 8. Okay, that's the chain rule. Okay, but always this was left alone. Okay, now if you're doing an undoing, if you have an antiderivative and you have the square root of that, that was probably what was left alone. That's the chain rule. And all this other stuff, that x to the 8, that was probably from the part where you say the derivative of it. So you should always start off by saying, I'm going to use a substitution on what was inside the parentheses. And if I do that, the differential du is equal to 9x to the 8, just like you did before, the derivative up there, but you added dx. Okay, you need that dx because when you take this problem, copy it, paste it. I'm going to move that x to the 8 to the back and put it here. Oops. Take this whole thing. And I'm going to put it in the back so you can see it. I have x to the 8. See that highlighted part, x to the 8 dx? I want to replace that with du. Unfortunately, in my du, I have x to the 8 dx, but I have that 9. So what I'm going to do is I'm just going to write here, I'm going to divide by 9. I'm going to take that 9 out there, and I'm going to divide it here. Or I'll do 1/9. Let's do 1/9. I like that better. So 1/9 of du is equal to that. So when I do my substitution, I'm going to take this out. I'm going to put that in, 1/9 du. So I'm going to take this out. I'm going to put that in. Okay. I'm going to take this out, and I'm going to put u in. Okay. And in actual fact, I will make it u to the 1/2. So I could do the antiderivative now. Oh, let me take that 1/9 out. So I'm going to take that out and put it in front. Constants can go up, but other numbers can't. So that I can integrate. So that's going to be 1/9. Antiderivative of u to the 1/2 is u to the 3/2. Divided by what? When you do an antiderivative, you use the exact same number. When I said u to the 3/2, it's going to be divided by halves. Okay, let's see. Okay, all I have to do to finish this officially is to replace the u. So u is x to the 9th plus 8. I have to back substitute in there. Like that. All right, and now I'm done. That's a regular substitution. Okay, I picked the inside. Actually, in this case, they told us what to use for substitution. For this one right here, they're telling you again what to use for substitution. And this square root of x and that dx is probably part of the du. Okay, it has to boil down to something easy. This one right here, they're not telling you what to do, but what's the antiderivative, or what's the derivative of cosine? Well, minus sine. So if I say u equals cosine, then du equals minus sine of x dx. Or in other words, if I want to take that minus and move it to the other side, I can just do that. Minus du equals the sine of x. So you see, so now I can start doing all this substitution stuff here. I can take the sine of x. Let me just write it here next to the dx. Sine of x dx. I'm going to replace that with minus du. And this cosine, I'm going to replace with u. So let me actually do it. So I'm gonna change this to d minus du. Okay. That there's gone. And I'm gonna change this to a u. Okay. And I can reorganize this to be minus 7/3 times the integral of u raised to the minus 1/2 du. So you see how I moved the stuff away. I moved the numbers out, and now I just have this, and so this is just minus 7/3. Antiderivative would be u to the 3/2 divided by u raised to the, oh, that's minus, so it's between 1/2. Divided by 1/2. Okay, plus c. Am I done? I got the antiderivative right? Everything's good? No, it's not good. What's wrong? There's no u's in this problem. So what do I have to do to finish it? I have to replace the u with what? What was the u originally? It says it right there, 2 lines up. What is u?
Oh, sorry.
Sorry. And if you want to, you could make that. Just be careful because I don't like that way. I'm gonna put a square root in front of it. Oops. That's what I want to say. Okay. All right. This is another regular antiderivative. There's a cotangent. If you look at that and take the derivative of it, you get all this cosecant stuff. That's all part of that. This one's a little tricky because it's one of those ones that you'll never see on a test, but it's an antiderivative. That's an inverse trig function. So let me just show you what the inverse trig function is. So that the inverse secant of x plus c is equal to, just put this up. This is a 1. This is a du. Okay, so this is what you might see. If you were to look it up, that's what you might see. Do you see how these are similar? By the way, I'm putting x's in here, but if they were used, it would be a little easier to see. I want my equation up there to look like this equation down here. So what do I have to do to make these look like each other? What does u have to be? Okay, this is x to the 7th, and this is u. So what should u be? U should be what? X to the 7th, right? U to the 14th, that's just u squared. If u equals x to the 7th, what does du equal? Du equals, take the derivative, and what do you get? 7 what? To the
6th.
dx. Isn't that what I have here? 7x to the 6th dx. So basically, if I use these substitutions, I end up with that. And that is simply this. If you look it up in a table, that's what you get. So what's your answer going to be? So that's not the answer. The answer is going to be, you can't use u's, but what was u equal to in this problem? What is u?
X to the 7th.
So that's what I put in here. Okay. And that's what I get for. This one, and there's another one later on. this guy right here is a similar one. It just boils down to an inverse trig function. And I don't really ask them on the test. I want you to try to do them, but you're not likely to see this. To see how you could change that into that, and that's just equal to the inverse sine. Okay, so this is what you can find in any book or on a table of integrals or whatever. Oop. All right. Okay, and that looks, you see how similar they look? The only thing is that e to the 6x, that's part of the differential. This, if you let u equal e to the 6x, then the derivative is going to be 6e to the 6x. So let me write that down. U equals e raised to the 6x. Du equals 6e raised to the 6x dx. Okay. So this and that are just 1/6 of du. So let me get rid of that 6 way over here. Okay, so all of this, I can use this whole thing, except there's going to be a 1/6. Okay. And then you just have to replace put the u back in the end. So you're going to end up with e to the 6x. Here. Okay. That's regular substitution. We did that last time. Okay. What are the two different types of integrals? I'm asking somebody at home. Slade, what are the two types of integrals? Hello? Slade,
Hello?
what are the two types of integrals? Can you be more definite?
Yeah, there's a definite and indefinite.
Yep, those are the two types of integrals. Very good. Selena, what do they tell you? What does the definite integral tell you? What does the indefinite integral tell you? These were all indefinite integrals, and what did they tell you? I don't want to be anti what you're going to say, but could you say something? How about you, Jonathan? I don't want to be anti Selena, but do you have something that's not so anti? Tell me about what indefinite integrals tell you.
What
Anti.
the- Antiderivative?
Yes, that's what the integral tells you. These have all been antiderivatives that we just did. Okay, and they were all antiderivatives with substitution. Acacia, what does the definite integral tell you?
The area.
Does. And so let's go down to this. So when I get to this one right here, question number 6, that's just an area under the curve. But look at this. If I just take that period, it's so the decimals will just do it for us. Okay. That the area under the curve. So which curve? Let me just, it's not here, but maybe it is here in the question. Let's see. No, I'll put it in here. Anyway, so here's what I'm going to do. I'm going to graph this. Not that one. I'm going to graph this one right here. Okay, so when you look at this graph, you're going from -5 to 5. This graph is perfectly symmetrical. Okay, it has positive area on one side and has negative area on the other. So if you're going from -5 to 5, you can see how the positive area over here would cancel with the negative area over there. Okay? Someone see that? There's that. And then there's the other one. Okay, the purple area is negative. The green area is positive. And you can see if you're going from one side to the other, it's perfectly symmetrical, so it's going to cancel out. It makes a lot of sense. Okay, so it makes it sense that the answer is 0. But you could have done a substitution. You could have said u equals x squared to the 4th. Okay? When you do that substitution, I just want you to see this. When you're writing an integral the way it's written there with dx, the limits of integration are x equals -5 to x equals 5. Okay, that means in this graph, if I were to graph it, x equals 5 and x equals -5, that means the area between those two. Okay? So it would be, let's see if I can get it to stop doing that. What did I say? X less than 5. This one would be x greater than 5 minus 5. Okay? That's what they're talking about. That's the area that they're talking about, and those are x equals. So I wrote x equals. But when they do a substitution, and here they did the substitution, they replaced the x squared plus 4 with u. And then that x dx turns out to be du over 2, or 1/2 du. So that's that. But you can't leave the limits of integration, can't leave it as -5 and 5. You have to change it to whatever it is if you are in the u variable. So now you're not in the x variables, you're in the u variables. So u goes from, you plug -5 into this function here, and you get 29, you plug 5 and you get 29. So you have 29 to 29, it gives you 0 also. Okay? All right. Here's another one. The thing with these are, if they're written this way, you can really just get the answer. Okay, you can use substitution here if you want to, but you don't have to. Let's talk about ones where you have to use. And so here's one, you have to use the right notation. So let's go with this. Okay. So they tell you that u equals x to the 5th. So what is du equal to if u equals x to the 5th? Anyone besides Alicia? Sebastian, what is du equal to? It's a derivative of x to the 5th. X to the 5th, don't even look. What's a derivative of x to the 5th? X to the 5th power, you bring the 5 down. 5. X to the what? I'm not,
X to the 4th.
4th, and then you have to remember to put the dx in. The problem with this whole section is that sometimes you're doing derivatives and sometimes you're doing antiderivatives. When you're doing a differential, you're doing derivatives. So all those regular rules apply. Okay, let's move on here. So what can I replace with this with? I haven't heard from who's next on my list. Luke. Are you there?
Are you talking to me?
All right, sure, Eric, I'll talk to you. What can I replace this x to the fourth dx with?
1/5.
1/5 of du. Correct. Okay. I want it this way. No, 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 no. Okay. What is f of x to the fifth power? What can I replace x to the fifth with? Look at the beginning of the line in front of us. What is x to the fifth equal to? Somebody say it. Pavani. What's x to the fifth equal to? From the line before, what's it equal to? Acacia, x to the fifth, the line before, what's it say? The line 79, what's the first thing it says? Line 78 says the same thing. X to the fifth is equal to what?
U.
Thank you, Jonathan. It's u. Okay, but now these limits are x equals 0 and 2. You can't leave it that way. You have to change it to use. So what are they going to become? Hold on, somebody's missing here. I don't know. Pavani, want to tell me what? So I need to change that integral from x equals to u. So it has to be u of 0 and u of 2. Okay, I'm almost done. All I need for you to do is from that line before, one that Jonathan just talked about, that said x to the fifth equals u. What is x to the fifth if x is equal to 0? Anybody? What is 0 to the fifth power?
Nothing.
0. Okay, now here's the harder one. What is 2 to the fifth power? I'm using your phone. No, you're doing something else.
Just texting some,
Ah.
sorry.
Somebody help me. What is 2 to the fifth power?
32.
Thank you, John. 32. Okay, so we changed this to, you can't do anything more than that. That's the end. Okay, so where the limits were 0 and 2 before, now they're 0 and 32. Okay. One thing you can do if you want to be clever, I think these are the same. Okay, I think they're the same, but I can't verse it. So line 79 and line 80 should be the same. Oh, they are. Look, 102.41. You know why they're the same? Because I'm using a spreadsheet that has F already in it. It doesn't matter as long as the function is the same function. Somewhere there's a function up here. Somewhere in here is a function where I define F of something. I don't know where it is. It's on this sheet somewhere. I don't see. But anyway, it's able to do it. If you do that, just make up any function you want and see if you get the same answer, then you know that this integral with all those x's is the same as this integral with all the u's. Okay? All right. If you guys know what you're doing, then this problem number 10, this is the last one. Somebody's going to help me with it. Start with, if u equals the sine of x, what does du equal?
Negative cosine x?
The regular cosine x.
Oh.
I know. It's hard because you're mixing integrals. And so du equals cosine x what?
Yes.
Okay, so what do I see? So here's the problem I'm trying to work with. I can move this cosine from here. I'm gonna cut it out of here and I'm gonna move it there. And you see that 5? I'm just gonna take that right outside of the integral. Okay? Good. Oops. Okay, so I haven't done anything except move some stuff around. That's just algebra and the property where I can move the 5 out. Okay. Am I ready? Let's go for it. Oh, there's an answer. 0.625. You can't have an answer, but Desmos does because F is defined somewhere. Okay, let's change the variables. What did you say sine is equal to here? Look at the top. Sine is equal to what? Somebody? Anybody?
U.
I think we got it. Then you. What's cosine dx equal to? Du. Okay, now all I have to do the limits stay the same? Do you want to leave that 0 in pi over 6? Or do you have to do what? To evaluate u at 0. So what is u of 0 equal to? What is that equal to? That's what is u equal to? Sine? So that's the sine of 0. What's the sine of 0? I just ask Desmos. You could ask Desmos too. What is it? Okay, what about pi over 6? Can I leave the pi over 6? Do I have to do something with it? Do I have to do anything with that pi over 6 or can I just leave it that way? Someone answer the question. Not Jonathan. Pavani. Luke. Keisha. What do I do with that pi over 6? I don't leave it there. I have to evaluate it. I have to evaluate you at that point. Pi over 6. And what is u of pi over 6? I don't know. It's the sine of pi over 6. What's that? I don't know. It's equal to a half. Okay. All right. You guys were very helpful with that one. And I know it's on the quiz. So let's try the quiz. Okay. Quiz 10. Okay. I'm going to call on people again. Somebody want to volunteer for this one? It's super easy. Eric, you're unmuted. Go for it. Which letter is used for integration with substitution?
It's the U.
It's you.
The letter U.
That's correct. Okay, say the following. Anybody but Eric. Anyone? I'm waiting. Someone's gonna say it. It ain't gonna be me. I'm gonna do my fingernails while I'm waiting for somebody to say it. Go ahead.
So u equals log of x.
U equals natural log of x.
Is 1 over x dx.
Du equals 1 over x dx. U equals natural log of x. Du equals, so this one right here? I think so. Okay, 3. All right, what happens in line 8? Oh, and here's your choices. Let me do it this way. What did I say, line 8? Okay. These are the choices on the left. What happened? All right, so I have an integral, I have an integral, I have an integral, I have an integral. No integrals were done. But it looks like in the first line, I did maybe a substitution. And then when I move here, looks like I just used some properties. Oh, I evaluated the limit. So where it had u of 0, now it has 0. Where it had u of 2, I have 2 to the 5th. So which of these describes that? Finding the differential? No, back substitution, only the substitution part.
Would it be back substitution?
No, back substitution is when you go back from u's and get back to x's. That's what we call back substitution. This is actually substitution, but that's a definite integral. So it looks to me like it's substitution on a definite integral. But there's really no other choices. None of the above would be okay, but I think that's what it is, definite integral. You're doing the limits of integration, and that's as much as you can do. All right, I'm gonna go with that. Move on to the next one.
Professor, this quiz ain't it's not available for us.
Oh, well, it will be in a second. Oh, evaluate this. Well, this looks like, look, it's a multiple choice, so it must be inverse sine 1. 2, 2, 2. The difference is, I think that u equals e to the 2x. So I think it's going to be 1/2. It's probably that one. But you can check this. This isn't so bad. You could actually check take the derivative of that and see if it's equal to that. Right. Okay, the last one. This is the hardest one because there's a mistake here. Okay. You have to be careful with this one. It says, uh-oh, what happened to my problem? Where'd you go? Here it is. So it says, here's the worksheet, and I want to do all of this. So let me copy this down. Put it in my worksheet. Okay. Use the regression and the approximate area. So there's approximate area and the regression. It's already set up to estimate how many graduates there were in the 10 years after 2010. So A must be what? A is the first value. What's the starting value? 10 years after what? 2010. So put a 10 in there. Okay. And what about, is that okay? 2020, that's the 10 years after. So that's okay. Okay. And then it says, this is where it's mistake. If you're using it 12, if you're going to do 12 times a year for 10 years, how many rectangles are you going to use? 12 times a year for 10 years is how much? Every month. How many months are there in 10 years? Sebastian, how many months are there in 10 years?
You said how many months are there in 10 years?
There we go. And there's the answer, 5816. Okay. Must have missed something. That's correct. Correct. Substitution on a definite integral, correct. This one was correct, but I didn't go over it well, and that one's correct. Okay, so let's talk about this one right here. Why? How did I do it so quickly? Well, because inverse sine, I let u, u equals e to the 2x, du equals e to the 2x times 2 dx. divide both sides by 2. And that tells me that all of this is just 1/2 of du. This whole integral becomes the integral of 1/2 du times 1 over the square root of 1 minus u squared. All of that is inverse sine of u. So that would be, so it's 1/2. So it'd be 1/2 the inverse sine of whatever u is. It's either the two x's. Okay, any questions on that? Okay. Why don't I let you try quiz 10? So quiz 10, you say is not open?
It says it's past due.
Yes. I found that. Yes, it is not open and I cannot do it.
Okay. All right, hold on. Let me make it so you can do it. What you're talking about? It says that it's, it doesn't say that it's past due. So
It's
I'm gonna-
open now. Yeah.
I'm gonna make it due on, it says it's due, was due on the 5th.
Yes.
So what's today, the 14th? And I can make it first. All right, I'm gonna make quiz 10 due on the 24th, 21st, so you have a while to finish it. Okay. And then I'm gonna open up all the other quizzes. So on next Thursday, I will open up all the other quizzes. Okay? All right. Any questions? All right, I don't have anything more that I want to cover per se. So that's that. If you don't have any questions, I'm going to turn the live stream off. But if you'd like to hang around and hear my talk, it is all about you. Gives me your chance to insult me and put me down when I'm feeling not too bad about it. If you'd like to do that.
Yes. No, I'm just
Okay.
kidding. No, I'm just kidding.
Go for it. All right, so here's what my talk is about. So this is this conference is for remote learning conference. So I said, what's the best price to charge for Lemonade? So this is a demonstration of remote project-based learning with interview style testing. That's what you're doing. When you break up into those groups, that's your project. When you get tested by interview, that's your interview testing. And this is, I want to tell them how they can do it in a math class. So I'm sharing what goes on here. So the first thing that I say is I can't just give you interview tests. I had to prepare you for it. So my whole course is designed to prepare you for this interview testing. Okay, so what are the types of questions? You know, spoken only questions, written and spoken. Yes? Those are the types of questions that you can ask in interview style. This, maybe you've never seen this, but this is how I see it on HonorLock. It gives me a video of what you're working on and it tells me what question you're on and I just click on them. Anyway, but this is interesting. I don't think, which one of these do I give you the most? So I give you, so the level of presentation questions could be data. I'm always, those presentation questions at the end, those are the ones that make the difference. Those have to do with your project. The ones that we just did with whatever what you to do every week. So data, mostly I give you formulas. Rarely I don't give you formulas, but sometimes I don't give you formulas, but I tell you what to do, like an average rate of change one, I might not give you the formula. Mostly I give you the formulas. And then sometimes I give you the formulas and the answers. Mostly I make you find the answers, but they're not hard to find. Anyway, I could make it harder, I could make it easier. I go right down the middle. And the two types of answers are either writer or speaker. Okay, so you can either present it in mathematical notation or you can present it in spoken notation. Right, that seems about what you do. Okay, the important thing here is that you present your answers. This is sort of new from other classes. So normally you just give an answer, but here you have to actually present it. So what does presenting mean? It means give all the like we are using a regression to solve it. What regression are you using? Did you have a period? You have to explain the period. Anything that goes into it, you have to do as a speaker. The writer stuff is just the math notation. Okay, so I have created this little worksheet for them. You recognize this Desmos worksheet here? I mean, it looks like a Desmos worksheet. So I'm going to have them put in the cost of lemonade in that letter C. So that's one of those floating variables. And then I'm going to have them, all this stuff just pops up automatically if they pick the type of lemonade they want. And then you can just click on the maximum and get the maximum. This would be profit. The purple graph is the profit. Okay. And then the writer would just say what the point is and the speaker would say what it means. All right, so so then I break them out. I'm going to break them up into demonstrations. So I'm going to make them break up into groups like you do. And I'm going to have a presenter, a producer, a presenter, a speaker, and a writer. I'll talk about a liaison because somebody has to connect the groups that are at home, if there are any. Anyway, this QR code will take you to this Desmos thing. And what is it? I have it here. It's this. So when it comes up automatically, it'll come up with $1 in there. Oh, that's not it. I changed it. Hold on. Let me just copy this because it won't come out. It won't. I don't think it will. I think it will. Just won't do it. Just being a jerk. Hold on. Okay, so this is the little thing, Desmos thing. You recognize these Desmos things. So if the lemonade is $1, okay, and you click homemade lemonade, that's just a linear regression. You get that, you get those regressions. You just have to click on this to get the maximum profit. If you want the other lemonade is cans of lemonade, it's a different price for the maximum. And the only difference between these is the type of regression. They have different linear, exponential, quadratic, and log regression. Okay, sugar-free. Boom, each one of those gives them the maximum. Okay, so the writer will say, describe the point, and the speaker will say, according to the whatever regression, and the market data collected, the maximum profit will be this, that, and the other thing. Okay, fine. So here's the data that I provided them. But this comes from a class of 20 people. 10 people would buy the lemonade at 75 cents and so on. But I could collect data right now. You guys are going to have even fewer numbers, but if I have people that talk, I could collect their data, ask them what they would pay, how many people would pay for each one of these prices, and then I can save the Desmos sheet, to copy it, and I can send it out in the Zoom meeting so they can all have a new one that's updated. And it automatically, if I just change this number to whatever 20, it just, you know how Desmos works. This is all redone. Now they can click on the same lemonade thing and they just get a different price. Now it's $1.44. Okay. or they can change the cost and they can see what happens if the cost goes to zero, the revenue and the profits are the same thing. But if there's a certain point you can't do it anymore, the reason why you can't charge more than $1.90 or so, it's because the sales people won't buy it. After that, you see the red line is the sales. When you reach that point, you're not gonna sell any. So the maximum, if it costs $1.50, you charge $1.69, and that's how you make the most amount of money. Given this data. That interesting? Okay. I thought it was interesting because you could take this spreadsheet home and do it. You could, if you want to decide what, the reason I say lemonade is because you guys ever see kids selling lemonade on the side of the road anymore? Not anymore, but they used to. And if you want to know how much, you want to know how much to charge, this is the way to do it. All right. So then I'll ask them to what was the price so they get to present it. Okay. And then I'll talk to them about how they can save this sheet and attach it to how it's saved and attached to tests, and how I can give you feedback about taking interviews. When you're taking an interview test, I can talk about soft skills and stuff like that. These are all my goals in this class: to encourage community. I don't know, do you guys get along? Do you have more or less of the same community as you would in a face-to-face class? I know you work in teams. Last night, some guy said you can leave when you're done meeting group, and he left. I said, why are you leaving? He said, well, we all have a text, common text or whatever. He was texting them during class so that they could leave right away. That was interesting. I call on you guys all the time. I like that you answer. I think that keeps you more on your toes. If I don't call on you. I like that you keep your video on, but you don't. If I talk too long, which I do, I have live stream, so you can watch it later when you zone out, because I'm betting that that's what some of you are doing. I encourage technology. Oh, the buffet of learning is the whole thing about having vocabulary words and reading and speaking. So having all those things on a test gives you more diverse way of answering questions, so you know it's not just solving equations, so you can get a better grade. Generally speaking, the lower grades are not as low, because you can almost always get some points from vocabulary or reading or something. So I find your grades are not as bad. Actually, in general, passing is much higher in this class with the interview stuff. Soft skills and interpersonal skills, I feel like you get more of them than you would in a regular remote class or certainly an online class. And the other thing is, if you do this stuff in the groups, I can write a letter of recommendation for you. Okay. And I have stuff to say. I can say Alicia's group was always prompt. And Sebastian worked well. He worked well in teams. Companies love it when you talk about collaboration. Also, when you do your research project, I'll say, Aiden did a research project that was very interesting. All right. Anyway, I'm going to give them a quiz. You don't have to take that quiz. But I do have this last bit of student comments. This is what I got between you and the other class, that it was unique. I'm guessing it is. I don't know any other teacher who does this stuff, so unique is good. Also, people seem to say that they were prepared for the exams. The exams were not, like the quizzes helped you prepare for the exams, and maybe the tests helped you prepare for the midterm, and maybe the midterm helped you prepare for the final. Are you afraid of the final? Because it's going to be hard, but not because you don't know what type of questions I'm going to ask. The diversity of questions improved grades. I heard that in this class. I heard loved live stream in both classes. I haven't heard any complaints. This is your chance to get me to take that off. Nobody has complained that the exam is ordered. Once in a while, I hear somebody and it does say, oh no, I should have said something else. But that's the worst that has happened. And then they didn't do that badly, or they just moved on anyway. So not being able to go back didn't seem to be a big problem, and I haven't heard anyone complain about this having to speak. But then again, there are people who dropped, so maybe they had problems with this. I don't know. And in my other class, somebody preferred paper and calculator, but like the calculator is very limited compared to Desmos. Desmos is very public, and I use Desmos in every class. When I used to use the calculator, I used to have to show the TI-83 versus the TI-84 because they had different commands. So I can't teach, if you use a calculator, if I use a calculator, I can't teach you all different calculators. And then you have to buy them. So anyway, if anybody has any more comments about this course that I can share with the people tomorrow for distance learning, if there's something you would like to see more of that you think would make it better. I got these ideas from talking to students, and you are students. So I flattered that so many of you stay at home, because I think that means you think that you can get as good an education at home. Like Sebastian's here all the time because he knows that he can't get a better education at home. But Alicia's usually not here. She used to come all the time and then she stopped coming, but she was at home. So I assume you were getting stuff at home. What brought you into class today?
Like consider.
Oh.
It's too lazy to waste gas and go home.
Oh, so you're already here. Oh, okay. No, this class, my problem with this school is that this class is sold to you as a face-to-face class. And then you come in here and then I go and make it high flex. It's still face-to-face, but it's high flex means that you could stay at home. And I wouldn't teach it just face-to-face because that's, to me, I don't know. I feel like I want to learn from the world. You guys are teaching me what works, what doesn't work. You are contributing to maybe making remote classes better. So I would like to have more classes. I'd like to have students that want to be in a HyFlex class. I would like Sebastian to have known that this was a HyFlex class ahead of time. And then at least he could have come and knowing that it was a HyFlex class instead of signing up for it and saying, hey, where's the rest of these kids? Nobody's here. Anyway, I just think that the school doesn't have any vision for remote classes. Maybe I'm wrong. Do you guys have classes that are more? Anyone have remote class that they love? This class. Oh, thank you.
This class, my English class is all online and it's like kind of sucks.
Yeah, the English, I spoke to one of my friends who was an English professor during COVID, and she did HyFlex, and she said all the students came back. She said, that's funny. You're losing your student. I'm not losing you. You are staying at home. That's not, she said they didn't stay home. They came in. They couldn't learn from home. And I think
It feels like it's easy to like kind of go through the motions of stuff sometimes, like to just kind of like not really learn everything that you're trying to learn. It feels kind of easier online. But I haven't been in school since online became really popular, so this is like my first time being back with that. But it seems kind of like less engaging, I guess, because also like I feel like memory is like spatial too. Like you remember things when you're somewhere, and like when everything's just a Zoom meeting, it kind of like blends in. It kind of all blends in.
Well, that's why I think visual is important. I don't nag you guys to keep your videos on, but I think keeping videos on is an important thing to do because it gives you visual context when you're learning stuff remotely, something to look at. When you're in class, tell me you're not looking at my shoes. No, honestly, I never look at shoes. I'm not that sort of person, but I remember being on a train. And the other new trains, the double-decker trains, do you know what the problem is when you're on the bottom layer? You just drive by and you see everybody's shoes. And I was like, oh, look at that. People do really care about shoes. And that Sex in the City, anyone ever see Sex in the City? All they do is buy shoes. Everything, when she's depressed, she goes and buys shoes. I'm like, when I get depressed, I eat something I shouldn't eat. But she would buy shoes. Anyway, the point is, I think people in a classroom get to have more stuff to look at. So I kind of agree with you in that respect, but I think that for math, it's kind of intense. You have a lot to look at, so having it remote is probably just as good. I don't know. Any other comments that I can share with these people tomorrow? Otherwise, you're free to go. I know it's early, but I will stick around and answer questions. And you're all free to go, and I may or may not be around on Tuesday. Depends on how Miss Rule I like this. What?
Good night.
Good night.